The long wait is finally over, and Tesla's most talked about budget electric car has officially stepped into the spotlight. Whether people call it the Model 2, the Model C, the Redwood, or the Model Q, they are all referring to a single groundbreaking vehicle that Elon Musk has now confirmed with 19 essential features that completely reshape what an affordable EV can be. This script blends earlier details with newly added insights, giving the most complete explanation yet of Tesla's cheapest electric car. After years of speculation, blurry factory leaks, investor guesses, and endless rumors, the car is no longer a mystery. Elon Musk has personally announced the 2025 Tesla Model Q, finally ending the debate. And it turns out to be one of the most aggressive deals Tesla has ever crafted. Many people assumed the Model Q would be built only in Mexico, but Musk has revealed a surprising twist that changes everything. Tesla has decided not to rely solely on one country. Instead, the company will build the Model Q in Mexico and another unexpected location, giving Tesla a strategic advantage that few saw coming. With this move, the company aims to produce the most affordable EV in its lineup without sacrificing the performance, range, or technology that made Tesla famous in the first place. The question many are asking now is how Tesla can make a sub-$17,579 vehicle that still meets the company's high standards. The answer lies not in cutting features but in three major technological leaps that rewrite the economics of EV manufacturing. Next generation LFP battery cells, massive Giga casting, and an all-new 48-volt electrical system. Together, they give Tesla a cost advantage no competitor has been able to match. The first and biggest cost breakthrough comes from Tesla, adopting new lithium iron phosphate batteries. Traditional EV batteries rely on expensive components like cobalt, but LFP chemistry removes cobalt entirely. Cobalt is not only costly, but often connected to ethically difficult mining conditions. By eliminating it, Tesla cuts battery costs by roughly 30% immediately. Because batteries normally make up 35 to 40% of a vehicle's total manufacturing cost. Dropping the price of the battery pack by nearly a third means Tesla saves between $2,400 and $4,500 on every Model Q it builds. This reduction alone allows Tesla to reach price levels that competitors have been unable to achieve. But the advantages of LFP are not just financial. These batteries last more than double the cycles of standard lithium-ion cells, which means the Model Q's battery can deliver over 3,000 full charge cycles without significant degradation. Consumers benefit from reduced long-term ownership costs because the battery ages far more slowly. Other budget EVs like the Nissan Leaf and the Chevrolet Bolt still use older chemistries, which cost more and wear out faster. Tesla's shift to LFP puts the company in a position to offer both affordability and long-term reliability, a rare combination in the low-cost EV market. The second major breakthrough is Tesla's Giga casting method. Traditional automakers assemble hundreds of metal pieces to build the rear section of a car. The average vehicle rear underbody is made from more than 370 separate parts welded together. This process is slow, expensive, and leaves many opportunities for manufacturing defects. Tesla's Giga casting transforms all but a few of these parts into one enormous casting, produced in a single shot. That eliminates complexity, removes hundreds of joints, and reduces manufacturing costs by around 30%. Production time also falls dramatically from about 3 hours to just an hour and a half per vehicle. One Tesla production line using Giga casting can output 45 vehicles per hour, compared to the industry norm of 18 to 22. This efficiency translates to another $2,800 in cost savings per Model Q, helping Tesla maintain profit margins even at a low sticker price. With Giga casting, Tesla can scale production faster, build more cars using fewer workers, and maintain highly consistent structural quality. These benefits give Tesla a long-term manufacturing advantage that traditional automakers are still struggling to match. The third advancement is the new 48-volt electrical system, which Tesla first introduced in the Cybertruck and now uses across its newest platforms. For decades, the automotive world relied almost entirely on 12-volt wiring. It worked but required thick cables, heavy components, and offered less efficiency. Shifting to 48 volts allows Tesla to cut the wiring weight by 50%, dropping it from 80 to 90 pounds down to only 40 to 45 pounds. Reducing weight in a vehicle directly improves energy efficiency. Every pound removed boosts efficiency by about 0.3%, which means the wiring weight reduction alone boosts range by 7 to 8%. This also gives Tesla the option to use a smaller battery pack without sacrificing driving distance. Because the vehicle consumes energy more efficiently, it delivers more range per kilowatt-hour. The higher voltage system also reduces electrical losses, allowing components to operate more effectively. These advantages further drive down production costs while improving performance. Combined LFP batteries, Giga casting, and 48-volt wiring allow Tesla to sell the Model Q for well under $17,579 while still providing excellent durability, range, and charging performance. The result is a budget electric car that not only meets Tesla's standards, but stands far ahead of legacy automakers trying to compete in the affordable EV segment. Many car companies claim to offer low-cost EVs, but their cars often suffer from limited range, slow charging speeds, and lower quality construction. Tesla's technology stack allows the Model Q to offer long-range, fast charging, and industry-leading efficiency at a price point that rivals cannot match. Now the biggest surprise: Tesla's decision to manufacture the Model Q not only in Mexico, but also in India. Most analysts and investors assumed that the bulk of Model Q production would come from the new facility being built in Nuevo León, Mexico. The location offers proximity to U.S. markets with low labor costs. However, Elon Musk announced that Tesla would launch a parallel production program in India. This significantly expands Tesla's global footprint and gives the company an advantage in pricing, logistics, and market reach. India's manufacturing labor costs are among the lowest in the world, around $3.80 per hour for skilled automotive workers. This is lower than China's $5.60 per hour, and dramatically lower than the United States at $36.80 per hour. Vehicle assembly typically requires 18 to 22 labor hours per car. This difference alone saves Tesla between $1,800 and $2,200 per Model Q produced in India. On top of this, Tesla is negotiating incentive packages that may include reduced import duties on parts and tax benefits for domestic manufacturing. These incentives could further reduce production costs. India also has a rapidly expanding battery ecosystem powered by major industrial companies investing in LFP battery manufacturing. With the government pushing local battery production, India is expected to reach 80 gigawatt-hours of annual capacity by 2025. That is enough to supply batteries for more than 1.6 million Model Q units every year. Producing batteries locally eliminates shipping fees and bypasses the import tariffs that currently raise battery prices by around 22%. Avoiding these tariffs saves Tesla around $1,700 to $2,200 per car. Combined with labor savings and government incentives, Giga India could drastically reduce Tesla's production cost structure while allowing the company to sell the Model Q the lowest possible price. India also provides a strategic export location. It has close shipping access to Europe and Southeast Asia, with logistics costs about 8% lower than shipments from China. Given Europe's strong EV demand and rising tariffs against Chinese vehicles, India becomes a valuable export base for Tesla. Through India, Tesla can reach consumers in Europe, Asia, and the Middle East, while keeping shipping expenses low. The country itself is also an enormous market. With a population of 1.4 billion and 5 million new car sales per year, India's automotive sector is expanding rapidly. EV adoption is projected to grow at a 35% annual rate through 2030. Manufacturing the Model Q in India positions Tesla to capture a significant share of this massive emerging market. With these efforts combined, Tesla's global manufacturing network becomes stronger than ever. The Mexico plant covers the North American region, while the India plant handles Asia, Europe, and beyond. This dual approach allows Tesla to scale production more aggressively than any competitor, attempting to build low-cost EVs. The next major question is whether the Model Q truly deserves the title of Tesla's best deal ever. The answer depends on how it stacks up against its closest rivals, especially the BYD Seagull, one of the most successful low-cost EVs from China. The Seagull currently sells for around $11,500 in China and is expected to be priced around $15,000 in global markets. It is undeniably cheaper than the Model Q, but the price difference becomes smaller when comparing what each vehicle offers. The Seagull provides only about 190 miles of range, whereas Tesla's Model Q is expected to deliver around 275 miles. The Seagull charges at just 30 kilowatts, while Tesla is expected to offer up to 170 kilowatts. At that speed, the Model Q can add around 180 miles of range in just 15 minutes, roughly 6 times faster than the Seagull. Tesla's extensive supercharger network makes long-distance travel easier. While BYD does not control its own global charging infrastructure,